All right, Descartes' rule of signs. What he figured out is that if you look at a polynomial and you look at how many times the signs change, you can tell how many positive and how many negative real roots you have. It's kind of a cool thing. And I have it here, and usually I put in other words, yada, 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 okay? But I don't have one of those because it's kind of too hard to explain in a shorter way. So I'm just going to show you how to do it, and we'll do some examples, and hopefully that will be enough. It's not particularly difficult. It's just kind of got a lot going on, so. Okay, this one's kind of a hard one. I thought we would just start straight off with the difficult one, and then they'll just be easier after that. Okay, so we're going to determine the possible number of positive real zeros, negative real zeros, and imaginary zeros for this polynomial. So how many times it could cross the x-axis on the positive side, how many times it could cross on the negative side, and then how many imaginary zeros it could have. Not how many it will have, but it could. Okay, so the first thing we're going to do is we're going to look at the signs of each term, and we're going to count how many times they switch from term to term. So this one's positive and it goes to a negative. So there's one. Negative to positive, there's another one. Positive to negative, there's another one. Nope, nope, nope. So there's three. Now with this, you take the number and you keep subtracting by 2 until you can't anymore. I know that's weird. So there's either 3 positive real roots or there's 1. Positive real roots. So if I had a super long polynomial and there were 6 sign changes, there could be 6 or 4 or 2 or 0 positive real roots. If there were 7 sign changes, there could be 7 or 5 or 3, excuse me, or 1. All right, so that's how that works. And then I'll show you on this little table how it all fits together. Sorry. Okay. To find the negative real roots, we have to plug in negative x and kind of rewrite the polynomial. Now, side lesson. If I have x to the 6th power, and I plug in negative x to the 6th power, what's going to happen? Okay, I've got negative x times negative x. That gives me a positive. Another one and another one gives me another positive. And another one and another one gives me another positive. So this doesn't change. If it's even, my sign doesn't change. I just get what I started with. Okay? If I have x to the 5th, though, and I put in negative x to the 5th, then I have negative x times negative x is a positive, times another negative x times another negative x is a positive, but then times another one is a negative. So it does change the sign. This becomes a negative x to the 5th. So if it's an odd exponent, the sign changes. Let me write that down, okay? If the exponent is even, the sign doesn't change. If the exponent is odd, the sign changes. Okay? So let's plug negative x in for all of these x's. So this is even, so the sign doesn't change. But this is odd, so this sign is going to change. So I have a positive 2x to the 5th. This is odd, even, so the sign stays. This is odd, so the sign changes. Even stays the same. Odd changes. And then we have a constant, so that stays the same. All right, so now we're going to change, or we're going to count the sign changes again. So these are all the same, but here's a change. So here's 1, 2, 3. So there are 3 or 1 negative real roots. Okay, so now we're going to come down here. We look at the degree of the polynomial, and there's a total of 6. So I'm just gonna fill this in. 6, 6, 6, 6. If I have a possibility of 3 real roots, I could have 3 positive real roots. I could also have 3 negative real roots. Well, that would give me 3 and 3, that's 6, which would give me no imaginary roots, right? Because they've got to add up to 6. Now, another possibility could be 3 positive real roots, 1 negative real root, that's 4. How many imaginary roots would I have then? 2. Okay, another possibility could be 1 positive real root, 3 negative real roots, that's 4. So 2 imaginary roots. And what is the very last possibility? Okay, 1, that's 2, and 4 imaginary roots. Okay, so this one is really, really involved. Okay, I've got just a couple more to show you, and then the lesson will be done. But I'm going to do that in one last video.